All right, boys and girls, welcome to day 2 of section 4.7. I'm actually going to start with example 6. I'm skipping over example 5. You guys can take a look at example 5. I am going to have you do some graphing problems, but basically I'm going to have you use some sort of graphing utility. You can use your calculator if you have one. You can use an app, or you can use Desmos. And basically all I really care is you understand the transformations. Okay, so you guys will have practice on that and you can look at example 5, but I'm going to go ahead and start with example 6. Okay, so in example 6 we're going to be using the inverse properties. I did include the inverse properties at the beginning of the Nearpod. I would say either use your textbook or include it in an index card, because you are going to be referring to that, okay? So it's the composition functions. So the first one that we're going to be doing is tangent of arctan of 23, okay? So it says, if possible, find the exact value. All right, here we go. Whenever we have an inverse function inside, we should be looking at the domain. So in here, the domain of the tangent inverse is basically all real numbers, okay? So 23 is an acceptable value. So when I take the tan of the tan inverse or arctangent of 23, what happens is, you guys have done this before in composition. I know for a fact you did it in integrated 3, but the tangent and the tangent inverse basically cancel each other out. So all you're left with is just 23. Okay, that's it. It's a composition property. Okay, so again, you can either look at the properties on page 320 or make an index card. Okay, all right, so now we're going to move on to part B. Okay, so for our next example, we're going to do sine of arc sine of pi. Once again, whenever your inverse is inside of the parentheses, you should be looking at the domain. Well, the domain for inverse goes from -1, and I should really have brackets, to 1. Now, if you don't understand that because it's pi, another way of thinking about this is, remember, if this is the domain of the inverse, then this must be the range of sine. And the range of sine goes from -pi over 2 to pi over 2. Okay. Now, pi is basically outside of the range for sine. So what happens is this. No, baby, I apologize. Okay, what happens is pi is outside of the range. So we would not be able to find a value for this one. So unfortunately, you can't do this, okay? So this would be not possible. Okay. Oops, that's not how you spell not possible. Okay. Again, and that's because it doesn't fit in the range. Okay, this is not a value that you can actually find because it's outside of the range. Okay, so anything would be like not possible, not defined, or undefined, and you can write any of those. Okay, or no solution. All right, so again, you cannot do this one. All right, let's try another one. Okay, so the next one that I'm going to do with you is cosine of arc cosine of -0.82. Once again, if the inverse is inside, then we should be looking at the domain, and then the domain of cosine inverse or arc cosine goes from -1 to 1. And if you notice, the value of -0.82 is actually within the domain. Because it's within the domain, this is an acceptable value. So again, what happens is cosine and arc cosine, or of course cosine inverse, they pretty much cancel out. So your answer here should just be -0.82. Again, this is like through composition. This is a property, and And that's it. Okay, so there's not much work to it. You're pretty much just simplifying by using the properties. Okay. All right, let's move on to the next example. Okay, so for example 6, I'm going to do B, and this is right underneath example 6, which you guys can take a look at the book, and you guys can try A and C on your own, or you can look at those as an example. I figured I would do B, even though they do it for you. I thought it would be a really good one to go over with you, okay? So this is arc sine of 5 pi over 3. So it's different than the 3 that I showed you because now we have the inverse outside and the sine inside. So whenever we have the sine inside, so the regular trig function, not the inverse inside, then we should be looking at the range, okay? So the range for sine goes from negative pi over 2 to pi over 2. Okay. Now here's the deal with this one. Okay. And it's kind of like the example that I gave you, the on I think it was, what was it? I think it was B as well. The one where it had pi. This is outside of the range. But we are going to verify that we can still solve for this by finding the coterminal, okay? So we're going to find the coterminal. Maybe I should have showed you this one before I did the other one, but so let's do the coterminal angle to see if we can do it, okay? So the way we find our coterminal angle, which we've had practice before, again, let me write coterminal, is we're going to take 5 pi over 3 and subtract by 2 pi. Okay. Okay. All right. And if we do that, 5 pi over 3 minus 2 pi, and I'll let you guys do, you know, the whole common denominator multiply. By now we should be a little bit faster at finding this. Okay. So we should get negative pi over 3. Okay. Again, I kind of just did mental math because by now we should be a little bit quicker. Okay, common denominator, multiply, and then subtract. Okay, so our coterminal angle of 5 pi over 3 is negative pi over 3. Now, is negative pi over 3 between these intervals? And the answer is yes. And because it is, we can take the, let me write it in a different color. We can take the arc sine of sine negative pi over 3. Okay. And so again, now we have arc sine and sine, and this fits within our range. So if it fits within our range, we can definitely simplify this. And again, because of composition, the inverse and the sine will just cancel each other out. So our answer should just be negative pi over 3. And again, this is just part of the property. Okay. And so now I'm going to kind of go back and explain, if you're wondering, why did we take the coterminal here and not over there? Okay, so now let me show you. Okay, so I had previously showed you this example. Again, I want to remind you, when we have the inverse function on the inside, we always look at the domain. And so the domain here should be between -1 and 1. But then if you're thinking, well, pi, how can I compare pi to that? And if it doesn't make sense to figure out, well, how is pi between -1 and 1? Then the other alternative would be to take the range of your function on the outside. So the range of sine is negative pi over 2 and pi over 2. So now you can definitely tell, okay, well, pi is definitely outside of this range, right? Okay, so now going back to the previous example, if I want to take the coterminal angle, okay, then I would do the same thing that I did earlier, pi minus 2 pi. And boys and girls, if you take pi and you subtract 2 pi, you now end up with negative pi. And guess what? Negative pi is still outside of the range, okay? So because it's still outside of the range, this is still not we're not able to simplify this. Okay, basically it's not solvable. So again, it'll still be not possible. Okay. All right, awesome. All right, again, it makes sense if you either look at the book for the properties of composition, um, or um, or write them in the index card so you could see how they basically just cancel each other out. Okay, composition, simple as that. Okay, that's kind of the goal. You want it to simplify. Okay. All right, moving on to the next example.